Alrighty. Next, we have a triangular pyramid with a right triangle base with legs of 8 centimeters and a hypotenuse of 10 meters. I think these are all supposed to be 1 unit of measure, so centimeters. So there's a C missing here. Centimeters. Do that in black. That would be a really difficult question. And has a volume of 144 centimeters cubed. Find the height. Find the height. So for volume of a pyramid, just a reminder, volume is equal to 1/3. We have the base, which is a triangle, times the perpendicular height of the pyramid. So that's what we're trying to find. We are trying to find the H. Your base, since it's a triangle, is going to be base times height over 2 of the triangle. So our base itself is a right triangle. This is our base. It has a leg of 8 centimeters. I'm going to put it on this side. A hypotenuse of 10 centimeters, and then I need to find the other leg in order to find the base, because one of these is going to be the height, and this is going to be our little b. So I need those in order to find the area of that triangle. Since it's a right triangle, I'll just do Pythag. So 8 squared plus x squared equals 10 squared. And x ends up being 6 because of Pythagorean triples. So x is 6, or that base is 6. So I'm going to take the big base is going to be that little b, which is 6, times the height, which was 8, over 2. So 6 times 8. 6 times 8 divided by 2 is 24. So I'm going to take that 24 and plug it into our formula. Our volume was provided at 144, 1/3, 24 times height. Now, however you choose to balance this can be different. If you want to get rid of the 1/3 by multiplying each side by 3 first, or you can multiply the 24 by 1/3, which is what I'm going to do. And that gives me 8. So 144 equals 8 times h. I divide 144 divided by 8. My calculator needs batteries. 18. So the height is 18 centimeters. And then we can look at a composite question. Let's see. Yeah, we've got some composite questions to look at. So the first one here says, find the composite volume if the cone is being removed from the square pyramid. So for this one, we're going to take the volume of the pyramid, and we are going to be subtracting the volume of the cone. So that's all we're having to do. We're not having to take into account, again, satuable surface area. For taking 1 and just completely subtracting it out. So for the volume of the pyramid, I'm going to take 1/3. It is a square base. So the volume, or the area of that base, would be 9 times 9. And then the height is 8. 9 times 9. I'm going to switch calculators because this is not working. There we go. 9 times 9. Times 8 gives me 648, and 648 divided by 3. Let's see if that divides evenly. Does divide evenly and gives us 216 meters cubed. So that's the volume of the pyramid. And then we look for the volume of the cone. So that's going to be 1/3 pi. The radius of our cone. See that red line that's going across is the diameter with a 6 pointing to it. So that tells us the diameter is 6. So the radius has to be 3. 3 squared. And the height is also 8. 3 squared is 9. Clear. 9 times 8 divided by 3 is 24 pi meters cubed. And so now I just have to subtract these. So I'm going to take my pyramid, my 216, minus the cone, which is 24 pi. And we're going to round to the nearest tenth for my final answer. 216 minus 24 pi equals 140.6 meters cubed. Yep. And then we have one more composite. I think I'm going to do this as a separate video though, so hold tight.